Hello, this is Jim McKeeth, and welcome to this developer skill sprint on saving and retrieving settings using FireMonkey SaveState. This is the C++ skill sprint for January 14th, 2016. This skill sprint works with all platforms and all languages, so while the examples will be in C++, it also works with Delphi and Object Pascal. Those general information links there provide information links to the doc wiki, the community site, as well as the new platform status site where you can find out what versions of OS are supported by your favorite development tools. Our agenda, we're going to first introduce you to SaveState, talk about the persistence versus transient options, the way some of the different platforms behave a little differently, and then some usage considerations, and then have a link to a great class helper. So the purpose behind SaveState is that on mobile devices, the background apps sometimes can be terminated from memory. So what that means is if you're using an app and you switch from that app to another app, that app's still there in memory and the state's maintained automatically because it's in memory. But sometimes it'll get pushed out because of another app needing more memory. That's just the way the mobile apps work, the mobile OS works. When that happens, an event fires that gives your app an opportunity to save the state so that when the app's launched again, the state can be restored. So this makes it easier for you to persist the data in your forms or anything else that you want to persist that would set the state up of that application. By default, it saves it in transient or temporary storage so that it's not permanent storage. For example, if the device reboots or if the device runs out of hard drive space, it could clean up the temporary storage, or if they run some sort of cleaner application, it could clean up this temporary storage. So there's a number of situations that could result in the storage being cleaned up. For example, on iOS, if they back up their device and restore it, it may not be restored in that situation. But you do also have the option to save the state to persistent storage, which can be useful as well. So this is all done through the tform SaveState class. All FireMonkey tforms and tform3ds have a property called SaveState, and this is an instance of the tform SaveState. And then they have an event called OnSaveState. So in the OnSaveState event is when you access the SaveState property and you persist any settings you want to persist to the stream. So SaveState.stream is a memory stream that you can use to load and save settings from. If you want to change it from the transient storage, or the temporary storage, to permanent storage, then you can modify the storage path. So make sure you modify the storage path before you read from it. And keep in mind that if you previously persisted it to the transient storage and you change the storage path, now you'll be reading from the non-transient storage, which means you won't be reading your previous state. So keep that in mind. Also, you can change the name, and you can actually change the name in order to have multiple values written to the storage. So if you want to store maybe the form in one place and then you want to store some other data in another place, you can activate that by just switching names. So you switch to the default name or the name of your other settings you want to persist. So there's some slightly different platform behaviors for this, and the different behaviors really come down to the behavior when you're using the transient state storage, which is the default storage state if you're not specifying a path. Okay, on Android, the transient storage or this transient state is stored in the native activity, and the native activity discards that if the app is terminated manually. So if you manually swipe the app to terminate it, then it discards that. And that's the way the OS institutes this behavior. So the way you can test this is under developer options. You can set it to don't keep activities, and that way as soon as you switch away from the activity, switch away from your app, the activity gets pushed out of memory, just as if it was pushed out in the background. On iOS, Windows, and OS X, it still persists the state when the app is manually terminated. So it's much easier to test, and it will by default, as soon as you close the app and relaunch it, it's saved and restored the state if you've set up OnSaveState. On Windows and OS X, the default location is the temp folder. Okay, this is a shared temp folder that all apps can access, And so potentially you could have another app accessing your save state. So keep that in mind for security purposes. Or another app could stomp on your save state. So definitely something to consider if you're storing it in the transient location, the default location. Now, if you change the storage path to, say, documents folder or home folder or something like that, then this behaves the same across all of these. Okay, so really the difference is how it's being stored, where the storage path is on the different platforms because of the variations in the OS and how that behaves based on that platform. So let's take a look at SaveState in action. The great thing about FireMonkey is you can build, design, and prototype your app on Windows, and then it runs across all the platforms. So that's what I'm going to do. I'm going to build this, show you how it all works on Windows, and then I'll demonstrate it on the other platforms for you as well, so you can see how it works there. And I'll point out the subtle differences as I go along. So I've got a simple little app here. I'm going to go ahead and run this right now. It doesn't do anything interesting at this point, but you watch here as I type something in here. Hello world. If I close it and reopen it, it starts over at the beginning again. That's what you normally see in an app. If you take a form, add an edit box, run it, that's exactly the behavior you'll see. Now, on Windows, that's what we expect to happen. When we're done with an app, we close it, we reopen it, and it starts over at the beginning again. Now, on a mobile device, what happens though is users switch between apps, right? The ability to switch between apps, app runs in the background for a while. The problem is that the OS doesn't know when you're finished with an app or when you're planning to come back. And at some point, it will decide, oh, you must be finished with that app because you've launched 25 other apps, or this app's really big, or it's been a while, or whatever this criteria the OS uses. And it decides to close down the app that's in the background. And you lose all your work. You lose everything you've been working on. So that's where SaveState comes in. So how this works is on your form, on any FireMonkey form, there's an event called OnSaveState. Now this event fires right before the OS pushes your app out of memory on a mobile device. On Windows and Mac, it also fires when the form is closed. So I've already got a handler I've written earlier in here. So what happens here? On the SaveState, what I'm going to do is I'm going to use a binary writer, and I'm going to go to the SaveState property. So I have a SaveState property on my form, and it has a stream in it. First thing I'm going to do is going to clear that stream because I'm going to put some more data in there. And if I don't clear the stream out, I'm just going to keep adding more data. The stream will get huge, and I only ever read the first set of data anyway. So clear your data. And I'm also going to check to see if any of my edits have anything worth saving in them. So if they have content to them. You don't have to do this. You can persist an empty stream if you want to, but just for example's sake this time, I'm going to make sure that they have something in there before I save to them. If they do, then I'm going to construct my binary writer and I'm going to point it to that stream. And then I'm going to go through and write the contents of my controls to the binary writer, which then writes it to the stream. That's it. That's all you have to do to persist your form. Now you can persist other things in here. The binary writer is overridden. You can persist integers, singles, etc. So one thing that's important though is that the order you write these in must be the same as the order you read them in. Otherwise, if you, for example, write a single and try to read it back as a string, you're going to get problems. Okay, so make sure you're writing them in the same order you're reading them. So as you add new ones, add them to the end of the list and don't remove one. So if, for example, I remove edit 2, just write an empty string, and that way it remains compatible. So here it is, reading it in. All I'm going to do is create a binary reader, check the stream size. If it's greater than 0, there's something there. So I have a little label here. I just show that I've restored state because there was something in the stream. And all I'm going to do is use the binary reader to go through and read these values in the same order and put them back into those controls. So now I'll run it with that reader in place, or the save state in place, and I'll say, hello world. This is saved. And I close it and relaunch it. And we see that it saved my state. So This is the low-level use case, if you will, the underlying stuff that you need to understand how this works. A couple other things in here, these are optional, is you can change the storage path. So by default, it's going to store it in a temporary location or transient location. That means that the OS could push it out. At some point, that data could get lost. If you want to persist it permanently or semi-permanently, you could store it, for example, in documents path or home path or something like that. So that's an option as well. You can also change the name. Now, by default, it creates a name for it. This is the file name on Windows that it saves it to, and I'll show you that in a little bit. But you can change it to a different name. One reason you might do that is you could actually have multiple streams, multiple save files for your form. One point is if you do have multiple forms in your application, each form will have its own save file, but you could have multiple save files for a single form. So for example, you could have one save file that only has the contents of the edit controls or the controls on the form. You get another save file that has something else that keeps track of your state. Maybe you want to store the SQL query that they ran to get them to the point that they're at, or something like that. You could store that in a separate save file if you want to. You can store it all in the same save file if you want to as well, but this is just an added level of flexibility. So like I said, these two are optional. You probably are less likely to use the name, but if you do want, like I said, want to change it from being transient to being more permanently stored, then use the get document path or something similar like that. So there is a class helper here I'm going to show you. Let me show you this sample here. So this one has some controls on it, and actually I'll go back and show you the code here. There's two lines of code that are used, a load form state helper and save form state helper. So it's on the same event handlers, SaveState or create. And what that does is it uses this nifty library here, which is in Object Pascal. And it's persisted out as JSON. So it goes through all the controls in your form, component count, goes through all the components, says, hey, do you have data? You do. Let's turn it into JSON. Let's stream that out. Okay, so you don't have to worry about this if you don't want to, but you see it's two lines of code, and it's going to persist all the controls in your form. So I'll run this here. Oh, let's run the right one. And we'll type my name, Jim McKeeth, and I really like Android. Close it, reopen it, and it persists it all. So there you go. If you do want to change the location, you can just do that here by the same way you would here. So I just take this, save storage path, copy that, and we could paste that right here. And I could change the storage path to go from transient to permanent storage. That's it. That's all there is to using SaveState to save and restore the state of your application. So let's go ahead and take a look at this on a few other platforms as well. Before I do, I promised I would show you the files that get saved. So the transient location on Windows is the temp folder. So here we go. These are the files. So you notice it's the project name and then a form name in here. And if I open this guy up, we can see here is the strings with some binary in there because it's a binary string. Let's see, this would be the JSON version. So we see some binary, and then here's the JSON that I just persisted out. Now you'll notice here, this one's got a different name. This is when I was experimenting with changing the save name. So if you look here, see it change the name here, and there's the other file that shows up. So this one had two files that were persisted for it because at one point I ran it with the different name. So here's the helper version of the app running on Nexus under Marshmallow. I'm going to put my name in here. Jim McKeeth, preferred OS, Android. And I'm going to tap the home button here and then launch it again. And we see that my data is still here. Now at this point, the activity never left memory, okay? It was still running in the background. If I come out here and swipe to dismiss it and launch it again, we see now relaunch, we saw a splash screen, but my data is not here. Now the reason my data is not here is because I terminated the app. On Android, if you terminate the app, you lose the data. Now, so the way I can test this is I can go into developer options. So settings, developer options, down here at the bottom, it says don't keep activities, or right here in the middle of the screen. You scroll down to the bottom, it's almost at the bottom. Yeah, it's the very bottom of the scroll. Turn this on. And so what this does is this causes the activity to be destroyed as soon as your user leaves it, which then triggers the OS's persistence to persist that. Okay, so now we'll come back here. We see again, we got the splash screen, but my data's here. Okay, so the SaveState event fired and the data is persisted. If I do hit the back button from here, for example, though, that terminates the app. So if I bring up SaveState again, we see that it's lost it. But with that, I put my names backwards. You'd think I know my own name. With the setting here, though, in settings, switching over here, switching back, splash screen relaunches the app, restores from SaveState. All right, iOS, Android, or iPad here. So I launched it. You saw the splash screen. Just put my name in here. Jim. Last name McKeeth. Preferred OS. We'll say iOS this time because, hey, I got lots of devices. I can prefer all of them. Come out. If I tap to launch it again, notice we didn't get the splash screen. Okay, so it was still in memory at that point. But if I double tap on the home screen or the home button and then swipe to dismiss and then come back here and we launched it again, we saw the splash screen and the data is persisted. Okay, so this one, iOS, it does persist it even if you do terminate it. But then if you are leaving the app in the background and it gets pushed out of the memory, which happens to me all the time on my iPad, it restores it and keeps the state there for you. So very, very useful, very handy on the iPad. Here it is running on OS 10, Jim McKeeth, and we'll say OS 10 just to make OS 10 happy. And we launch it again. And there it is, restored my state, persisted it for me. If you want to find out where it's located at in here, just check out where the file is stored at. It's shared location. Check out the help docs for get temp path, and you can see exactly where the file is stored and take a look at it. A few usage considerations to keep in mind. You always want to check for an empty stream before reading from it, and clear the stream before writing to it. Otherwise, you'll keep appending to the stream and only reading out the original data, which won't be productive. Use the T-binary reader and T-binary writer to read and write from the stream. And I would suggest writing a version number as the first value in the stream. And that way you can test for compatibility when reading. So in the future, if you make a revision to your form and you've completely changed the way you're persisting it, you can determine if the data that's persisted is going to be compatible or not. You could either throw the data out if it's not compatible or create a migration path to read in existing data. To minimize incompatibilities, if you add new values to the end of the stream and avoid removing values, so let's say you take a control off your form, you can always write an empty value each time for that, and then it won't rearrange things. If you're not rearranging things, then it should remain compatible. Or you could consider using JSON, like the helper class I showed you uses, in order to make the data storage more persistent, or make the data storage more robust. A security note, don't persist sensitive information. If you have a credit card entry field on your form, don't persist that, especially on Windows and OS 10 because it's stored to a shared location and could be accessible in ways you aren't expecting. Also, if you're using the default transient location, keep in mind that the OS may clear that, and don't persist excessive amounts of data. Now, you're probably going to ask, what is excessive amounts of data? I couldn't find any hard, fast rules on that, but generally speaking, persisting text and numbers is fine, small amounts. If you're persisting a image or video or audio recording, that could take a while, especially on a mobile device where the OS may be pushing the app out of memory. If you take too long to persist, not only is it going to create a poor experience for the user, but the OS might say, oh, you're not responding and kill you. So keep that in mind. Only persist the minimum. If it's something more than that, you might want to save it ahead of time so that it's already saved. So for example, if they took a picture, save the picture to persist to temporary storage. And then later you don't have to do that during the OnSaveState. Here are some learning resources links for you. The most important one is the down at the bottom embt.co/sprint-SafeState. That includes all of these links as well as the additional resources, and the replay will be there later. We'll point out the link there in the middle of the forum, SaveState Helper. The first link is to Daniele Spinetti's blog post for the original Delphi implementation. The second link is to the post that goes along with the skill sprint, where I've made a slightly modified version that has different calling convention to make it easier to use from C++. So lots of great information, lots of great resources for you to get started using SaveState right away in your applications. So next time, Al Manarino is going to talk about cryptography with app tethering, encrypting and decrypting the data that's being sent over app tethering. Generally, it's not necessary, but some people want to be able to do that. And so if you're interested in that, take a look at this skill sprint. Again, the Tuesday skill sprint on the 19th will be in Delphi. The Thursday skill sprint on the 21st will be in C++. All times are based on San Francisco time, so check timeanddate.com and make sure the time zones are correct, as they've been known to change. Give me a brief moment to tell you about this limited time special offer. All 10 Seattle registered users get the bonus pack, which includes the new Object Pascal Handbook by Marco Cantu. This essential language reference is a modern language guide that includes new features of the language and the core runtime library, a must-have for any Delphi developer. Also get the Binder Converter Basic. It handles the heavy lifting when converting existing VCL applications into FireMonkey applications, so you can start taking advantage of multi-device development right away. And the Premium Style Pack includes premium styles for VCL and FireMonkey to make your application look great on every platform. For more information on these special offers, or to find out what the current offers are, please visit www.embarcadero.com/radoffer. Thank you so much for joining us today for this skill sprint. And now it's time for Q&A.
Okay, if you have any questions, go ahead and put them in the question panel in the GoToWebinar software. Get them answered for you. Yeah, so you can store it in any format you want. The first sample I showed was just writing the individual values to the stream, which is in storing it in binary. The stream itself is going to have is a binary stream, but you can store within that stream any format you want. Right, exactly. So the event fires right at the moment that it would be pushed out of memory, the OnSaveState, and then you can then restore that later. Yeah, so it just makes it easy. And someone had asked before if they could save it at a different state, different event, and you certainly could. You could certainly save it on any number of events. You could save it as soon as the user makes changes to the UI. You could persist it out. But the advantage of doing it this way is that you're not firing that so often. So for example, if you saved it every time the user made a change in the UI, then you would be persisting very frequently, and you'd have a lot more processing being dedicated to that. In the grand scheme of things, it's not going to be that much, but it could be, I guess, is the point. So this just gives you the OnSaveState event handler, gives you the optimal time to save that state. And then the SaveState class gives you a convenient way of persisting that. Now, so I get someone asked before also if they could do this in why there isn't a VCL equivalent. You could easily do this in VCL. The advantage of this one, as far as the way the stream is persisted, is on Android. The transient state is actually within the native activity. So Android actually has a mechanism for persisting this without having to write it out to the storage. It persists it in the activity. That's why on Android it behaves a little differently if you dismiss the app. It's because if you dismiss the app, then the OS says, oh, you really don't want this, so we'll just discard your state. Whereas in the other platforms, it's persisting it to a file, and then that file's reloaded. So that's the difference. That's exactly what's going on. So there's some interesting things going on behind the scenes. If you dive into the code for the way it's implemented on Android, you can see that it's stored in the activity. If there are any other questions, though, go ahead and put them in the question panel here, and we'll get them answered for you. Otherwise, I think we're about done. Thanks for joining us today. Oh, wait, here's a go. How does the OS know that you are done saving state so it can remove the app from memory? The event handler. So the way the event handler works is that when it executes, it calls your event handler, and then when you finish, it goes back, and so then the app can then report back to the OS that you finished handling that event handler. So for example, let's say you have like a button click. You could, if the user clicked on the button click and you did something that totally locked up the thread because it was busy doing processing, you could tell the button hadn't been unclicked yet, for example. So because that's the way event handlers work. There's other things you can do to prevent that. For example, if you were to spawn a thread, then the UI would remain responsive because that thread could then do the processing, and then the UI could then return. You could, so that would be the best way to prevent that. So if you were to spin another thread off from here, then it would go back and say, okay, we're finished persisting, and then the OS would say, okay, and push out of memory, and then your thread would never finish executing. So hopefully that answers your question.
And I like these skill sprints. They're really specific focus, on a capability. And again, as you said, you can use these same techniques on all the platforms we support. I think, Jim, we've had this conversation before about, and people asked, I think on Tuesday, about VCL.
Yes, it asked if this was supported on VCL or if it was just for FireMonkey. This is actually just for FireMonkey. The event and the property, the SaveState property, are just for FireMonkey. But the technique you could use on VCL as well. The reason this is implemented for FireMonkey is because Android has that unique behavior where you can persist the data within the native activity when it's being pushed out of memory. So both iOS and Android have that concept of an app being closed in the background, so you need to have an event that you can respond to for that. But then also Android has that ability to persist it into the native activity. So on VCL, you don't have an app get closed in the background randomly, and you don't have a native activity to persist it to, but you could just as easily save it to the temporary directory, either every so many seconds, or every time the form loses focus, or some sort of criteria that you decide is appropriate for your application. And then if the system crashes or whatever, you can have that saved so that you can pop back immediately, or you could just do it when the application closes and save it off on VCL that way. And it's just a matter of creating a stream, writing data to the stream, and then reading it back. And you could modify that existing code that I showed you for that helper, and it would automatically persist all of your controls. I don't think there's anything. Right now it's written around FireMonkey controls, but you could probably change it to work with VCL, I would suspect. If not, you could use RTTI with VCL pretty easily and do the same thing. So pretty straightforward.
Yeah, and I put the links to the GitHub and Daniele Spinetti's blog post in the chat window as well. I really love using the IOUtils unit. It just makes things so easy for documents folders and separators, all the things for pathing on all the different platforms we support. So if all of you that are with us have never used something in the IOUtils unit, check it out. It saves you if-defs and special code for volume labels on Windows versus no volumes on the other platforms and so on. It's just so easy to build up the right local storage or standard default storage, as well as other I/O utilities like iterating through directories and files and so on. It's a great unit.
Yeah, and even if you're just working on Windows, IOUtils and the TPath is so useful, even if you're just doing Windows. It's very cool. So here's a question here. Can I use SaveState for saving a vector of pointers to a class with the info of each pointer to a class in the vector? You should be able to. I can't remember there's quite a bit of overloads for the reader and the writer for different types, but so I can't remember if there's anything around vectors or pointers specifically, but you certainly could save singles or integers and all that stuff. So the fundamental characteristics of that could certainly be saved out. You just need to figure out a way to represent that, and you can totally save it that way.
I think you said you can save just about anything, right?
Yeah, there's like a dozen overloads on the writer at least. I just don't remember if that specific one's there. This is something on my iPad I see this a lot, where iOS has this thing where it takes a screenshot of your app when you switch away from it, and then when you come back, it shows you that screenshot, and then transitions back to the running app. And so many apps don't implement this on iOS. Even the built-in Apple apps, like Settings, for example. I'll switch back, and I go to touch, what I want the setting I want to change or whatever, and right as I'm touching it, it switches back to the default view of the app because it wasn't actually running and it didn't remember its state, and I'm in the wrong spot. So it's kind of frustrating. I think this is a really important thing that we implement this so that users are able to come back exactly where they're at. The same, if you have multiple tabs, what tab's the active tab? Persist that. If you can scroll, persist the scroll location. That sort of thing, so the user comes back to it and it's right where they left off, and it's going to make your users a lot happier.
Okay.
I had someone ask if you could use this to persist like a SQL statement if you were, for example, using a SQL query to pull some data from the database, and then when you come back, you would know exactly what the last statement was you ran to pull the data that's being viewed. You could totally do it for that as well. So.
Okay, Jim. Thank you so much for this skill sprint.